For our student presentation, we chose The Physics of Weightlifting by Megan Yancher, Chris Rocha, and Devin Saunders.
Hi, today I will be showing the physics of weightlifting by demonstrating the deadlift. The deadlift will help show the 3 laws of Newton. The first law is any object at rest will stay at rest until an outside force acts upon it. So the bar will not move until I begin to lift it. Newton's second law of motion is force equals mass times acceleration. So to get the force, we need to know the mass and the acceleration. To get the acceleration, we need the distance traveled and the speed or the time of how long it traveled for. The third law is everything has an equal and opposite reaction. So even though the bar is still right now, the force of gravity is still acting upon it and pulling it down, while the floor is pushing it up. Once I begin to deadlift, me and the bar become one body, so while lifting the bar, my feet are pressing against the earth, and the earth pushes against me. As I'm bringing the bar up, I need to overcome the net force of gravity. Once I do, the normal force and the gravity force cancel out, leaving the tension force from my arms on the bar. So both my arms are lifting the load, which is the force of gravity, and keep lifting it until lockout. So one thing I need to mention before I begin the deadlift is the bar weighs 80 pounds, or has a mass of 80 pounds. Right now, the bar has no gravitational potential energy, but once I lift it and lock out, the bar will have full gravitational potential energy. So as I'm lifting, my brother will start the watch and see how long it takes for me to lift it. So from the ground up, it's about 30 inches. So we'll see how long it takes for me to travel that distance. Ready?
Mm-hmm.
Right. So it's taken about 2 seconds for that to happen. So 30 inches in 2 seconds.
So we want to find the force that the Earth has onto the weight. So that is mass times acceleration. And the mass of the weight was 80 pounds, which equals 36.3 kilograms. So you take 36.3 kilograms and multiply that by the acceleration of gravity, which is 9.8 meters per second squared, gets you 352.8 newtons. So then we want to find the work Chris did to deadlift the bar. So you take force times distance. So you take our just calculated force of 352.8 newtons and multiply it by the height the bar was raised, which was 30 inches, and that equals 0.76 meters. So you multiply those together and you get 268.13 joules. And then if we want to find the power, which is the rate at which work can be done, you do work over time. So our work we just found of 268.13 joules, and divide that by the time it took to raise the bar, which was 2 seconds, you get 134.07 joules per work. Joules per second, I mean. And that also equals a watt. So you have 134.07 watts. And then finally, if we want to find the gravitational potential energy, which is the stored energy, so at its maximum height, we would take mass times gravity times height. So we take 36.3 kilograms times 9.8 meters per second squared times 0.76 meters, you get 270.04 joules.
In this next section, I will talk about the 3 book sources and the 2 website sources that we used for this presentation. Our first library resource, we chose the College Physics book. Senior contributing authors include Paul Peter Urone, California State University, Sacramento Roger Hinrich, State University of New York, and College at Oswego. The publishers for 2020 is OpenStax. The textbook content produced by OpenStax is licensed under a Creative Commons Attribution 4.0 International License. The copyright and publication date is June 21st of 2012. We used page numbers 143 and 157 included in Chapter 4. Down below on this page is also the link to the book if you need any additional information. For our second library source, we chose a book called Light and Matter. The author of this book is Andrew J. Porter, and the publisher is Benjamin Crowell. The copyright/publication date is 1998 to 2010 by Benjamin Crowell. This book is licensed under the Creative Commons Attribution Share Alike License version 3.0. We use several pages, which include page numbers 95, 127, 153, and 261. Attached to the bottom of this page is the book file where you will need to download in order to view. For the student presentation, we were required at least 2 library sources. We chose one more with a book called Mechanics from Newton's Law to Determine Chaos. The author of this book is Florian Scheck. The publisher of this book is Springer Heidelberg. The publication date is 2010, and all of the rights are reserved to Springer Heidelberg. The page numbers used were pages 2 and 9 through 12. Attached at the bottom is the link to the book where you can also view more information. For our first website source, we chose a website that NASA is responsible for. Also, attached to the slide is the URL for the website, and also attached to this is the first page of the article that we use, which explains Newton's laws of motion. Our second and final source is an article by Access Science that explains Newton's laws of motion as well. Attached is the URL as well as the first page of the website.